morning, everybody. Welcome back to the next lesson on analysis of frames. If you look quickly back at the program for the semester, the next item on the agenda, can I say, is frameworks analysis using the method of sections. Now, I've been teaching method of sections for a long time, and students always tend to struggle with this. They say, sir, it is so hard. Okay. You need to know your taking moments about the point. Yeah, you need to know moments. You need to know where to take moments. You need to know each force times distance. That's the easy bit. But you need to work at that lever arm correctly. Okay. And a moment is a force multiplied by a perpendicular distance. Okay, and the distance always goes at right angles through the point of rotation. Okay, people, now this is one of the frames I gave you in applied mechanics. The first part would be calculate the support reactions. The answers are there. I'm just going to fill them out because you should be able to know how to do this by now. So there's the reactions. Let me just fill it in nicely. Okay, so VD is 20.59 up, which is that over there. Okay, and then VA is going upwards like so, and HA is that to the right, like over there, like so, and I'm gonna write them in now. So VD is equal to 20.59 kilonewtons. And VA is 15.19. VA is 15.19 kilonewtons. And HA is 15 to the right. HA is 15. I'm going to just write kilonewtons. I'm not going to put the dot for space. Right. So there we go. So the first thing you do is you calculate support reactions like you know. As I said, you know how to do it now. I just filled it out. It was given here. Right, people, now, on Blackboard, I'm also going to give you a method of how to, the procedure, okay, to solve reactions. It looks something like so. I call it, the document, I call it Procedure to Analyze Frames Using the Method of Sections. You can see it's just almost one page, okay. If you get stuck, read through it, okay, and follow the procedure there. There I give you an example frame and where you make the cut line, which I'm going to talk about now. But yeah, I'm going to work through all these points on the next frame so that when you work through a frame and you read through the procedure, you'll see that the two will talk to each other. Okay, right, people. So the next step is you make an imaginary cut line. Okay, now I'm going to just change the color here. I'm going to make it so. Right, what you do is you cut through the members that you want to determine. Okay, and let's say I ask you to determine members BC, CE, and ED. BC, EC, and ED. Okay, notice they're all like in a vertical line there. Okay, I'm not going to ask you like a funny question, determine this, that, using the method of sections. I normally ask you members which fall in a line. Okay, so let's say you need to determine members BC, EC, and ED. The first thing you do is, excuse me a second. Oh yeah, I got disturbed there for a second. Alright, people, so what you do is you make an imaginary cut line through, I'm going to draw it like over there, like so. Okay, so we need to determine members BC, EC, and ED. Okay, right, the next step in the procedure is we need to assume whether BC or CE and ED is tension or compression. Okay, now, and so I'm going to assume that BC, I think if I'm looking at that there, I think that BC is definitely going to be in compression. So now I'm considering, are you listening very carefully? I'm considering tension or compression to one side of this cut line only. Okay, so I'm considering compression to member BC on the right side, so it's going to be something like so. And okay, and I'm going to consider EC to be in, I think EC will be, if I look at that there, I think it's going to be in tension, so I'm going to say, sorry. Okay, and I'm going to consider ED to also be, I think in, let me see if I look at that there, will be in tension, so okay, so notice there, I've considered only forces to the right side of that cut line there. Okay, right, so the next step is, are you tuning in? Take moments about any point on the truss. Okay, that means either at A, B, E, C, or D. Take moments about any points on the truss, considering forces to one side of the cut line only. So take moments at any point on the truss, but either consider forces on the right side of the section. Okay, when I say forces, I mean if I'm considering forces to the right side of the section, I'm considering the applied loads only, the reactions, and the forces in the unknown members there. I'm not considering forces in CD. I'm only considering forces 12, 5, 20.59, BC, EC, and ED. Okay? If I take moments but any points on the truss and I only consider forces to the left side of that section, it's going to be the forces BC, EC, and ED, and the forces 12, 3, 10, HA, and 15. But because we're human and we're lazy by nature, I'm going to take moments about any points on the truss and consider forces to the right side of the section only. Okay? Secondly, now remember I've got BC, EC, and ED as unknowns. So I need to take moments about a point on the truss so that I eliminate two of the three forces and find the third one. Okay, and what's the definition of a moment? It's a force multiplied by distance. So, I'm going to take moments about point C for a start. Why? So, remember we can take moments about any points. I'm going to take moments about C, so that means I'm going to eliminate force BC and force EC, and that will allow me to determine force ED. Okay, right, there we go. So, I'm going to say, let me do this. So I'm going to say at joint C. At joint C. Right, I'm taking moments. So I'm taking moments about there. So, and I'm considering forces to the right side of the joint. So BC, EC, 12 is all going to be out. So I'm going to be involved with 5 there. So it'll be 5 multiplied by. Now be careful. What's the definition of a moment? A moment is a force times the distance. Okay, so the length of CD is not the lever arm of that force about C there. It is the distance 2.5 meters. Can you see that? And it's clockwise with respect to B. So it's 2.5. Okay, minus 20.59. Why minus? Because 20.59 is clockwise with respect to C, and its lever arm is also 2.5 meters. 2.5 meters. Right. Are there any more forces? Yes, it's this one here. Okay. And this force is going clockwise with respect to B, so with respect to C, so it's plus force ED multiplied by. Okay. And what's the lever arm for this force? Alright, if I do that, if I draw a line, let me change the color rather. If I draw a line like so, okay, And can you see that little d there? That little d there, okay, is the lever arm for that force, okay? Because the force times that c is equal to, sorry, the moment about c for force ED is plus, because it's clockwise, ED times d. So it's plus ED times d. Can we work out d? I think we can, okay? Because there's my right angle triangle, and there's my force, okay? There's my lever arm. And in method of sections, you need to know your trigonometry very well. Okay, at this point, stop the video, work out little d. I'm going to do the same thing. Right, have you done your maths? I'm sure you have, and you're a math genius. So from there, I see that little d is equal to 2.5 multiplied by tan 30 degrees. Okay, you can work at the answer, and we can do it up here. We're going to get it as 1.44 meters. Okay. Right, so I'm going to change the color there. So it's 1.44. So let's see. Taking moments over there. 1, 2, 3. 1. I'm just counting my number of terms in my equation. So it's equal to 0. So therefore, we have one equation with one unknown. We can now determine ED. Okay. Okay. Do the calculation. Check me and see if you get the same answer. And what did you get? Right, for ED, I got 27.07 kilonewtons. 27.07 kilonewtons. Okay. And because I get a positive answer, it means that ED is in fact a tension member. So I'm going to just draw it in like so, to tell me that I've completed it. Okay. It doesn't look nice. I'm just going to do that. Okay. So ED is done. Tension member. Okay. Right. Am I done? No, I still need to determine EC and BC. Okay. Right. Now what I do is this procedure here, I just do the same thing. What's the procedure? Take moments about any point on the truss, considering forces to one side of the cut section only, and we're going to consider forces to the right side of there. So now I'm going to take moments about a point on the truss there. Remember, this one is done. I need to now determine either EC or BC. I'm now going to take moments about point E. So if I take moments about point E, ED is going to be out of the equation. EC is going to be out of the equation. I'll now be able to determine BC. So I'm going to say at joint E. At joint E. Right, so let's see. Right, I'm considering forces to one side of the cut line only. Okay, so let's see. I have, that's going to be minus 20.59 times 5, minus 20.59 times 5, okay, plus 5 times, okay, plus, because 5 is clockwise about E, plus 5 times 5, plus 5 times 5. Right, that's out, and it's plus 12, okay, you with me? Plus 12. Right, what's the definition of a moment? Definition of a moment is force multiplied by a perpendicular distance. Now, let's check it out. I'm going to draw. Right, if I take the line, if I extend the line of action of this force down to over there, okay, and if I draw a line through the point of rotation at right angles to that line there, then that little, oh, that's nasty. Ugh, you know, the software doesn't like me to do it at an angle. Here's my right angle over there, okay, and if I take that as little d over there, okay, let me make that d2, that's d1, making it d1, okay, d2. Can you see there that the moment of that force is equal to the moment of that force about that point is plus because it's clockwise about E, plus 12 times little d. Okay, So can we work little d out? I think we can. Okay, there's an angle, so do the trigonometry and work out that distance over there. Okay, I'm going to do the same. You do the same and check me. Right, people, did you do the calculation? Right. As I said a little while ago, you need to know your trigonometry. Okay, so for D2 here, I get D2 equal to 1.45 meters. So my lever arm there is 1.45 meters. Change the color here again. Right, so I'm checking. I've got 1, 2, 3. Right, okay. So that's the lever arm for that force there. And then, of course, about this point here, I must still consider BC. And about this point, BC will be positive about E. So it's plus BC times. Okay. And, of course, BC here, okay, the lever arm for BC is, there's my force acting for BC. So if I draw a line from the point of rotation, okay, up to BC like so, at right angles to there like so, and if I call that little distance, if I call it D3. Okay, D3. So again, so BC will be positive about E because it's clockwise with respect to E. There's my line of action of force BC, and if I draw a line through the point of rotation at right angles to the line of action of force BC, that distance D3 will be the lever arm for that force there. Okay, right. Stop the video, do the maths, the trigonometry, and check me out. Okay, see if you get the same answer I get. And what did you get for D3? Yes, I got 2.5 meters. So it's 2.5 meters. 2.5. Are there any more? I don't think so. So it's equal to 0. Right, I got one equation. I can now solve for BC. So therefore BC. Do your calculation and see what you get. And for BC, I got 24.22. Okay. 24.22 kilonewtons. And because my answer is positive, it means that BC is in fact in compression. Okay. So I'm going to just do it like so to tell myself that I have actually done with that one. Okay, so BC is a compressive member. Right. Are we done? No, we need to solve for EC. Okay. Right, so for EC, what do we need to do? What's the rules? The rules are take moments about any point on the truss, considering forces to one side of the cut line, and solve that one there. Can I take moments about this E? No, because I'm going to eliminate EC. Can I take moments about C? No, I can't, because I'm going to eliminate EC. Can I take moments about D? Yes, I can. I can take moments about any point considering forces to one side of the cut line only. So I'm going to take moments about point D. Alright, now let me just see if I can do something here quickly. I've cleaned the board, so to say. Okay, right, I'm going to take moments about D. So I'm going to say at joint D, joint D, right. So at joint D, that's going to be out, that's going to be out, that force is going to be out. Right, so let's see about that. Okay, and BC will be out. So what's going to be considered? To be the 12 kilonewton force, and of course, member EC. So I'm going to say, and it's 12 plus or minus with respect to D. It will be minus because it's going anti-clockwise with respect to D. So it's minus 12 times. And what's the lever arm for that force? For that force there? Because it's acting at right angles to D, the length of CD is actually the lever arm for that force there. And that distance there is 2.887. So it is 2.887. And EC, is it clockwise or anti-clockwise with respect to D? It is anti-clockwise, so it's minus EC. What did I do there now? Right. Now, is CD, is the length of CD, is that the lever arm for EC? No, it can't be, okay? Because if I extend, let's take a nice pinky color. Alright. And if I extend the line of action of that force of EC like so, and if I draw a line at right angles through the point of rotation, at right angles to that force there, then that angle inside there will be a right angle. Okay, and of course, the length of that there, D4, is the lever arm for EC. And as I'm saying again for the 1000th time, you need to know your trigonometry. You need to know the definition of a moment. It's a force multiplied by a perpendicular distance. I'll say that again. I've extended the line of action of that force. Notice I can either go back or that way. It doesn't matter. That line there is still the line of action of that force. Okay, it's acting that way, anti-clockwise with respect to D. So if I find D4 there, then that is the lever arm for force EC. Right. Do the calculation and check me out. Right, people, did you get the answer for D4? Yes, it is. Just happens also to be, it's not the same, it just also happens to be 2.5 meters because of the geometry. Are there any more? No, there's no more. Okay, about D, that's out, that's out, that's out, that's out. So it's minus 12, okay, is equal to 0. Right, so I've got one equation in one unknown, so therefore I can solve for EC. Okay, so work it out and check me out. And what did you get? You should have gotten 13.86. Sorry, hang on. Very important. You must, from my equation there, I'm going to get minus 13.86 kilonewton. And what does the minus sign mean? This minus sign means that my assumption that EC is in tension is not correct. It is actually, or not actually, my English is getting bad. Okay. It is actually in compression like so. So therefore it's compression. Okay. So people, you can see that it's a bit of a long procedure. You need to know your trigonometry, and you need to know force multiplied by that perpendicular distance. You need to know that. Okay. So people, as I said earlier, there's the procedure. Okay. I'll follow this procedure here. Okay. If you work through that there, that's the procedure I've worked through for every single joint. I'll work through this procedure 3 times now, working through there. Okay. So very briefly, when you get a frame, we first calculate the support reactions. Okay. Then you make a cut line through the members you need to determine. Okay. Then you take moments about any point on the truss, considering forces to one side of the cut line only. You can either consider left or you can consider right. I normally just take, human beings will normally take the shortcuts. That means we consider forces on the side of the cut line which has the lesser number of forces. The lesser forces you have, the lesser room for error. Okay. And then you take moments about the point when you start. Take moments about the point which will eliminate the 2 of the 3 to find the third one. Then you take moments about the second point to eliminate 1 of the 2. And then you take moments about the point to find the third one. And then you're done. Okay. So if the question was, there says consider find forces find member AB and AC, what I would do is I would do this. Okay. I will take a cut line through AB like so. Okay, and then assume member AB to be in compression and member AE to be in tension. I would do that over there and consider forces either to the left of that section, to the right. Notice there, I only cut the 2 members there. You can cut any members, but you can't cut more than 3 unknown members at the same time. Okay, if I now need to determine members CD and ED, I make my cut line like so. And then I assume if CD is if it's in compression, I will say that's in compression. And if member EC was in tension, I will consider to be in tension and consider forces either to the left or to the right of the cut line, and taking moments about the points as I did for these 3 members here. Okay, so people, so that is how you find members using the method of sections. What I'll do in the next lesson, I'll take another frame and I'll consider one cut there, and I'll work through a set of members over there. Okay, I shall see you in the next video.